Hello and welcome to another video from Byte Analytics. In this video, I want to talk about a particular challenge which I came across whilst working with a user of a Power BI report. So I was given a business requirement and I needed to turn that into a DAX measure. And this is something which we come across from time to time. It was a relatively simple calculation, but certainly I had to think about it. I had to stop and think about what I had to create here. And it took some effort. And really, this sort of bounces back on the point that as DAX developers or people who work with DAX, it's often a common pitfall and something which we need to strengthen our skills on, and that is context. So let me talk you through the example I had and what I was given in terms of the business requirement. On screen, you can see a table here, and I've anonymized the data as you would. I've got items 1 to 10, and each item has a sum of a price. It's actually the selling price. I've just called the column price. And by default, when we add it to a table visual, the calculation comes out with the name of sum of price. It is actually just the price, and this literally lifts out from a table directly. So if I go into the table view, and if I click on the items table, you will see I have items 1, 2, 3, all the way through to item 10. I've got an index on the table just to help me sort that data, and then I've got a price for each one. So the key thing to note here, this is a table, and there is a fixed row context here by nature of having this in the table. So let's just go back to our report page here. Now, the requirement that I was given is that the user said to me they wish to see for every item, they want to see how many other items have a price greater than that particular one or the current one. So in our example here, the user wants to see for item 1, how many other items have a price greater than item 1, how many other items have a price greater than item 2, and item 3 and item 4, and so on and so forth until we've gone through all the items in the table. Now, on the face of it, that's quite a simple calculation. I used my best guess and I thought, great, I can do this. This is an easy calculation, so I'm going to go straight into it. Up until the point when I opened up the DAX measure and I was ready to type in what I thought I was going to do, and I really just had to stop and think about where do I make a start with this. So I'm going to jump over to PowerPoint now, and I'm going to show you how I broke down this relatively simple business requirement into smaller chunks and how that transitioned into my final DAX formula. So here we are in PowerPoint, and what I started by doing is writing out the business requirement clearly so it's in front of me, so I can refer to it from time to time and that I don't have to go through different variations of it. And for that reason, I've got it written out in front of me absolutely clearly. The business requirement is for every item, tell me how many items have a price greater than the current one. The other thing I want to clarify here is that the user wants this calculation to be part of the table. So they don't actually want a measure, they want a calculated column which sits physically inside the table. And that has a big bearing on how we approach this particular challenge. So let's dive into breaking down this business requirement into smaller chunks. Step 1 was to capture particular elements of this business requirement. For every item, tell me how many items have a price greater than the current one. This tells me I need to use some sort of aggregation. Now, when I read how many, it tells me that most likely this is some form of a count or a counting operation. And the function which came to mind was count rows, because count rows, you can use count rows or count as well. And ultimately, I want this calculation to sit inside a table, so maybe I need to count the rows of the table to start with. Step 2, for every item, tell me how many items have a price greater than the current item. In this case, I've highlighted price greater than. That tells me that we need to meet a particular condition. And when I think about condition, I think about a filter expression. Straight away in my mind, I can see the symbols less than, greater than, or equal to. And something tells me that I need to filter some sort of data element from the table that I've nominated above in the count rows expression. Let's continue. Step 3. For every item, tell me how many items have a price greater than the current one. In this case, I've highlighted for every item. Now, if you're familiar with programming languages, for every item is synonymous of for each loops and looping over and iterating over your data. So in my case, this gave me an indication that I need some sort of iteration over my data, over my table, which I have captured previously in the count rows, and for the one that I wish to filter on. So now that tells me something quite deep here. We're building on a formula, at least conceptually, and that tells me that I may need to filter down my table, and the filter is going to allow me to iterate over my table. But at the same time, I want to count the rows of the output of that filter function. Lastly, for every item, tell me how many items have a price greater than the current item. In this last step, I've highlighted current item, and this really was the point where I got stuck. Up until the count rows and the filter expression and the iteration, I was seeming to make sense of this calculation itself up until the point I got to current item. So think about this in a calculated column. How do I actually refer to the current item? Because that's the item I need to compare to within the filter expression. So there turns out there is a function which is called earlier. And the earlier function is something which I've heard of. I've used it before in some capacity, but I certainly didn't have the understanding of that function as I do now based on this particular scenario. So the earlier function allows you to jump back into a context which is visible inside the table that you're looping over. Let's jump over to the next slide and we can make more sense of this. On this page, you can see two table examples. On the left-hand side, I've used the filter function, and when I use the filter function, by default, filter will introduce a row context. So filter takes in a table as an argument, and then it iterates over that table, and for each row, it will create a row context within the filter function itself. Now keep in mind that we need to create this filter function within the table itself as a calculated column. So with that comes something else which is less noticeable, and that is that the column itself also has a row context. Because this is not a measure, it is a calculated column, the column is defined physically against the table, and the table has physical rows. And for that reason, there is automatically a row context defined at the column level. So what the earlier function allows you to do is access the row context, the default row context of the table, which is not visible inside the filter function. And by doing so, we can refer to the values of that row for our comparison. So now let's jump over to Power BI and see how we can put this calculation together inside a calculated column. Here we are in Power BI, and I'm going to go ahead and create a new calculated column on this table itself. Let's call this item count. And let's start by using our function which we identified, which was count rows. So count rows, press tab, and now we want to know which table to count the rows of. Now at this point I'm going to move down to the next row and I'm going to use the filter function. Because remember, we need to use the filter function to actually produce a table which is filtered before the count operation actually takes place. So let's type in filter. The filter function expects a table name as an argument. So what is it I want to filter? In my case, it is the items table. Let's press comma, let's move down. Now what's the filter expression? So what I want to do is actually filter on the item price. So let's type in price, and IntelliSense picks up what is available. So now that I have access to this column inside of the items table, I can say, this is my filter expression, by the way, this is the condition. I can say where the item price is greater than, and this is the part where by default, if I try and start typing price itself, it's not quite going to work in the way that we anticipate. So if I move down and close off that particular bracket there, let's press enter. And now I'm going to add item count to that table. And you see it's not actually working. It's giving me a blank result, which is not quite what I want. So let's go back there. And the reason for that is at the moment, there's no context for the row itself on the table. So in order to access the row context of the default table, I need to use the earlier function. So let's do that here. Let's type in earlier. And now let's add the price, the item price in brackets. And let's go OK on that. Now what you'll see is that our calculated column is returning a number, and the number correctly indicates all the items which have a price greater than the current row. So let's see how we can test this. So let's order our sum of price column. So we can see the first row we have here is the largest. So we're going in descending order from the largest price to the smallest, and there are 10 items available. So we can see that there is nothing greater than 89.99. Therefore, there's no value against that in the column. And for 57.99, we can see there is only one other value which is greater than that, and that is the 89.99. For 56.99, we can see there are two more items which have a price greater than that particular row. For 14.99, we can see there are three other items which have a price greater than 14.99. And that is true for all other items within this table. So remember, in this example here, we are using a filter function. The filter function defines its own row context, but if we want to access the default row context of the table, we can use the earlier function to jump back into the table and compare values as the function traverses through each row or iterates through each row. So in this example, we've looked at how we can take a simple business requirement, which may be simple on the surface, but turn it into a calculation or a measure inside of Power BI, and how we can break down the business requirement into smaller chunks and then literally translate those smaller chunks into DAX components or functions or iterators and elements of the DAX language, and then piece them back together to create a calculation or a measure to deliver your business requirement to your users.